Hello, I think we're live now. Let me just hear myself, make sure that I can hear myself. Let me just hear myself, make sure that I can hear myself. Yeah, cool. I mean, the music is not too bad. We can start playing again. It's not as loud, I guess, but what can we do? So welcome everyone. Welcome to another stream. And in today's stream, we're actually going to be creating some pipelines for our web crawler Rust project. And basically the aim of this this live is for myself to really learn how to use GitHub Actions, because it's one of those CI/CD providers that I haven't really used yet, even though I've got projects left, right, and center on GitHub. But yeah, I mean, I thought it would be useful for me to learn, not only for work, because I think work does use GitHub Actions for their CI, but also for me to just know how things work now. And it can't be that difficult, right? It can't be that different from something like GitLab CI or Azure CI. So that's what we're going to find out in this video. And let's actually just drop down some basic ideas of what we want to do in this stream here. So I want a big pipeline here. And in this pipeline, let's say we have mostly just build, right? So the idea is to create build artifacts at the very end. So we're going to build the web crawler project, and we're going to store the executables, the build executables somewhere, right? So that's what we want in the end anyway. But let's say I want some like fail fast stages first. So like something like cargo checks and stuff like that. Let's say I also want the actual build stage, right, where we actually compile everything. Let me just do this for a second, and then at the very end, we kind of want to include the we want to store, right, the artifacts. So save artifacts. So this is what we're going to push our like binaries or something automatically to a bucket somewhere, like a storage device. All right. So if you don't know what pipelines are, this may be a bit too much now. You probably don't understand what I'm talking about. But build CI/CD pipelines, continuous integration pipelines specifically, just make sure that your code passes through some checks and is built automatically and then kind of like deployed automatically as well. So that basically means that every time you push to a repository or make some changes in your like local project, and you push it to GitHub or GitLab or whatever it is, that change is automatically going to be picked up by the pipeline, and you're going to like check out the code. You're going to run these checks on the code, make sure the formatting is right, that your code style is correct. You're going to build whatever project you have with the code that you've pushed, and then at the end you're going to save the build artifacts somewhere. That's basically what we're going to do here. And if any of these steps fail, so like if your code checks aren't good enough, like if your code didn't pass the checks, the formatting checks or anything like that, or if your build didn't pass, if you've got a syntax error somewhere, or it simply just doesn't compile, then the pipeline should fail and you should get notified as well. So this is what a CI, a continuous integration pipeline, kind of does, right? So this is what we're going to be doing here. And recently, well, not recently, because it's quite, GitHub Actions is quite old now, but GitHub, if you host your project on GitHub, there is something called GitHub Actions, which is basically GitHub's own CI provider. And if you have a free project on GitHub, an open source project, you have free access to GitHub Actions. So you can run automated code on every little push that you make on GitHub, basically. However, if your project is private, if I'm not mistaken, by looking at the the pricing here, you get a certain amount of minutes a month that you can use up to. So for example, I think the free, we can take a look here. So GitHub Actions, if you look for free runners, you're going to get billing here. And the free tier basically has 2000 minutes per month, right? And you get 500 megabytes of storage. I think this is per project, per repository. Let me just make sure. yeah, so in GitHub hosted runners, so GitHub roasted public repositories get free access, free standard access. And for self-hosted runners, okay. There you go. For private repositories, each GitHub account receives a certain amount of free minutes and storage for use with GitHub hosted runners. So that means if you've got 3 different private repositories and they all have GitHub Actions, all of these repositories will share the total of like 2,000 minutes per month, right? So you can't just run whatever you like every time. Well, whenever you like, really. So you got to be a bit more conservative there, so you don't use up all these minutes. But we're using it on a free account, and I don't think I've got any other private repositories that are currently using GitHub Actions, so we should be okay for this live. So yeah, I mean, I hope that explained a little bit about what we're trying to do here. So now let's actually continue our Excalibur. So like, in pipelines, you usually have stages, and in these stages you have one or many jobs, and each job has something, it does something to your code related to the stage name. Basically, that's how you should view stages. It's just a collection of different tasks or different processes that you're running on your code, right? So I like to define my build pipeline something like this. I usually have a fail fast stage where it has very quick checks on the code, things like formatting, things like static analysis. Well, static analysis is not really quick, but I usually include it in this stage anyway. And then we have the actual build stage, and this is where you build your project for every platform, for every sort of like every kind of platform that you support. So in our case, we're only going to have one really, which is probably like Ubuntu 22.04 or something like that, whatever is available on GitHub. But in other projects, I also have things like building for Windows and Linux, different Linux devices on this build stage here, different actual like architectures, so building for ARM as opposed to building for x64 and so on and so forth. So you're going to have all these build things usually in your build stage. And then at the very end, when you've created some like build files in this stage here in the build, you usually want to sort of like make these artifacts, we call them artifacts, these build files available somewhere, right, for a release or something like that, so you can do automatic releases or whatnot. I'm going to stop the music for a second while I'm explaining. And yeah, I mean, this is where your artifacts stage, or I don't know what to call this stage usually, so maybe publish artifacts or something like that. This is where you'd put that kind of logic, you're going to take whatever files your build stage created, and then you're going to push it to usually like it's an S3 bucket or Azure pipeline storage, if you're on Azure, for example, Microsoft Azure, or in GitHub CI. I guess we're only going to just basically push these files to our free storage, which I think is up to 500 megabytes, right? So we can create releases in the future, right? That's what we want here. So that's what we're going to do. Let me just define this a little bit further by just putting the actual jobs that I want inside here. So for example, I definitely want a formatting job here. So in my case, it's cargo FMT. So format check. This is going to be one of the jobs that I want inside my fail fast for this project. And of course, we're using cargo FMT here because it is a Rust project. But if you're on, for example, if you're doing the same thing for a C++ project, you're probably going to use Clang format or some tool that achieves the same thing, basically. So Clang format tends to be the one that people use the most because it's free and it's kind of open source and very easy to use. So yeah, but in this time we're going to use cargo FMT. I'm also going to do a cargo clippy here, which basically does some sort of like static analysis. So static analyzes your code. Static analysis here. Let's call this, for now, let's just leave this as our fail fast sort of stage here. You might be wondering like where the tests come in, and yeah, you are quite right. I mean, I have forgotten to add another stage here, which would be the actual testing stage, right? So once you've built everything, you kind of want to run the tests as well to make sure that they all pass. So this is probably like your unit tests, your functional tests, system tests, whatever you do in your project, you're probably going to want it straight after your build here, because you're going to need the files from your build to actually, test, run the test, I guess. So let's add that there as well, so we can kind of just have a mental model of what we want to include in this pipeline here. So in my build stage, I'm just going to copy and paste this. This is going to be a cargo build here, and this is just going to compile for the platform that the runners will be running with. I guess I haven't really explained runners. So runners are typically the actual physical machines that are running the jobs on your pipeline. So there is actually a physical machine running somewhere, which GitHub hosts, and that machine is going to compile my code. Is going to do all the checks here beforehand, and so on and so forth. So whatever platform that has, so whatever OS that has, which I guess will be like some sort of Ubuntu build in our case here, because it's the free tier. We're going to run a Docker container, and that Docker container is going to have the cargo tools, and then whatever the cargo tools are inside the Docker container, they will be used for compiling for the platform of the underlying runner, right? So this is what we're going to do here. So the build that we're actually going to be creating is it doesn't really depend on the platform, because you can cross compile, but in our case we're only going to build for I believe it's Ubuntu here, so it's just one build here. So obviously if you want to have a different build, so for example you want to have a Windows cargo build, right, you have to find a Windows runner somewhere, and this will be like your Linux Ubuntu, I guess 22.04 build, something like that. And again, you can also have like ARM builds if you're cross compiling with the same platform. But I'm going to remove all of that and make this pipeline very, very simple, because we're only going to have the cargo build for whatever platform the runners have, right? So this is what we're going to do. Obviously, as I mentioned, we also have the cargo test here. So cargo test job. This is going to take all the build files that we've got generated here previously for our project, and we're going to use them in the test here. That's all we're going to do, right? And if any tests fail, ideally this job should stop the whole pipeline as well. And at the very end, we are going to just basically have a job to push or to upload build files, right? So that's what we're going to do here to GitHub. Yeah, so this is the plan for this pipeline, right? I'm going to make things a little bit prettier by just putting, I guess, boxes inside them here. And I'm kind of a perfectionist, so I like getting my boxes very tight. There you go. And then we're going to do the same for all of them, I guess. And here we are. Let's just pull that out a little bit. And this is essentially our build pipeline. That's what our build pipeline is going to look like in the end, right? So we're going to have something like this. So just to make sure, this is our GitHub Actions pipeline. This is what we're going to do. Can I make extra large? Large. There you go. There you go. So now let's actually get into it. So I'm going to start the music again, because we're actually going to start, I guess, coding, or the process of coding. I'm going to drink some water and get ready. So first of all, let's take a look at the repository that I've got here. So is the Matt Gomez Rustic Roller. This project is kind of like bare bones, I guess. So we don't really have anything at the moment here. Let's turn the volume down a little bit so I can hear my own thoughts. There you go. Or in fact, there you go. Let's turn this up on. There you go. It's better now, because it's hopefully it's the same volume for you guys, but I can hear less of it now. And do let me know if you can't hear myself or something. Please post in the chat. I'm glad to change the volumes. As I was saying, this is a very sort of bare bones project. I don't really have anything at the moment apart from just the cargo project, as well as my source code. So the idea is to create a GitHub Actions for this, right? So if I'm not mistaken, we can maybe click on the Actions tab here in your GitHub repository. And there you go, there's already a Rust, actions here for us. So if I just take a look at this one, can I see what's in there? Yeah. Check out v3, so it runs on Ubuntu latest. You see, so this runs on, tells GitHub Actions which kind of runner to run it on. Okay, so we can get a list, by the way, of the available runners. If you just Google for it, there is a page somewhere where they have the self-hosted runners. Whereabouts is it? And it's here somewhere. There you go. So these are basically the free sort of runners that you can get with GitHub Actions. I would possibly recommend here just using the Linux if you can, because the Windows consumes more minutes. So like if your pipeline is 10 minutes long, it will actually use up 10 minutes of your 20 minutes, sorry, of your free allowance. This is something that they say on the docs, by the way. So Linux tends to be the best option because it consumes less minutes, or is the cheapest, basically, if you're paying for it. So yeah, and Ubuntu 22.04 is the one that we want to use. Okay, and let's have a look. Archival test verbose. And if I take a look at what's actually included in this, because they might already have Rust installed, right? Supported software on 22.04. There you go. There is Rust already available here, so I don't have to use a Docker container, because typically with CI/CD pipelines, if you're talking about GitLab, if you're talking about Azure, or something like Jenkins or whatever, they tend to have like a very bare bones runner which doesn't have a lot of tools, right? But it has Docker in it, so you can actually go on Docker, on the Docker Hub, and search for the container that has the tools that you want, or you can create one yourself, right? This is not Docker. There you go, Hub the Docker, that's the one. So for example, if I wanted to have a Docker container that has Rust in it, I just go to the official Rust containers and look for the tags, and you can see that I have Alpine ones here. In my case, because the runner is 22.04, I'll probably try and match that. So if I look for Ubuntu, or in fact I think it's Focal, right? Focal, nope. It's going to be in here somewhere. I think it's by the actual name. So Ubuntu 22.04 Jammy. So Jammy is the one, right? So maybe if I search for Jammy, it has a base on that. Nope, it doesn't. So I guess all you can get here is Alpine, which is interesting. But yeah, I mean, you probably look for a different Docker container based on something that it's is relatively the same as the base runner. And then just run with that Docker, because then the pipeline will download the Docker, will initialize a Docker container, and then it will run all of the jobs inside the Docker container, so you have access to all the tools that you want. So maybe we can leave that for the end of the tutorial here, for the end of the stream if we have time, so we can actually use the Docker container. But yeah, I do wonder. So, Circle CI has a few ones here, which are pretty good from the looks of it. Yeah, Circle CI is another CI provider. And if I just look here, I wonder if they have any Ubuntu ones. Or Jammy. No. Why is no one supporting Ubuntu anymore? I search for Rust Ubuntu. What does it do? Yeah, I mean, I guess you can just get the sort of like the official Rust one, but the Debian package instead. So yeah, if you just use any of the non-Alpine ones, it should probably work on the base runner. Yeah, see, these are Debian ones, Bullseye. Yeah, maybe this should probably work or something. But yeah, we can do this at the end of the well, at the end of of our live if we've got time, so we can use an actual Docker container to run all of this. But it seems like we will be able to just use the base runner here, and admittedly, I'm just gonna sort of start from the very the very basic Rust GitHub Actions that they give you. So if you create GitHub Actions for a Rust pipeline on GitHub by clicking up here, as we said, there is a Rust example one, right? So yeah, let's commit these changes here and see what it does. So create Rust Actions. Yeah, let's commit directly into the main branch. Oh. Yeah, so we've got the workflows here, and then we've got the Rust pipeline here. And by default, I think it just builds, right? If we look at a definition, yeah. It's just building everything, which is definitely good. So we don't have to do that much work at all for this particular Rust. But you can see how this applies to other types of languages as well. So if you want a C++ actions, you can kind of create a new workflow here, and you can search for, first of all, see if you can search for a C++ one, if there is a C++ one. Maybe CPP, because you can't really search for the plus. Maybe not available. Maybe something like GCC build, no. Good. I mean, it brings me to my next point anyway. So if you don't have an example GitHub Actions here available to you on GitHub, you're going to have to write your own, right? So as you probably guessed already, so this .github/workflows directory is where all my GitHub Actions pipeline code will go into. So there's a YAML file inside this called whatever, it can be whatever name you want. .yaml, and that actually contains the YAML file that defines the pipeline on GitHub. And this is something that is kind of changes between, well, not kind of, it definitely changes between CI providers. So although GitLab CI, for example, has a YAML file as well, it's, the syntax is going to be different. The variables here that you're going to put, the way you define, the stages, the jobs is essentially different to GitHub CI, but they tend to be a YAML file. Maybe not in the case of Jenkins, because Jenkins doesn't use a YAML file. It's their own language, but it's kind of the same idea here. So you're gonna have to write your own if you don't already have an actions file that you can use, right? Slim, hey Slim, how is it going, man? Sorry, I just saw your message. I've been talking for ages. I'm not sure how long you've been there. I'm doing good, bro. I'm doing good. I hope you're doing good too. Today I'm gonna be writing some GitHub Action CI here for the Rust project. But anyway, and how do you know what to write in this YAML file? Well, GitHub has a very good documentation. So if you Google for GitHub Actions YAML here, there's going to be a page here which says how you define the workflows, right? So each of these files here defines a workflow. So this is the Rust workflow that we have. If you have one for C++, you're going to have a different file for the C++ one as well, and so on and so forth. This is just how it is. I'm trying to use mscripting with C++ and CMake plus going on. Ooh, yeah, I've never used mscripting myself, but that's something that I should probably do in the future as well, because it's a project that's gaining quite a lot of momentum. Having a WebAssembly created from a C++. So yeah, tell me, let me know if you succeed, man, or if you have a Git repository. I'd love to have a look at it and give you some feedback. You should also try with Rust. Rust also compiles to WebAssembly. Not through mscripting, I think, but through a different toolchain, I believe. I haven't actually tried it myself, so I don't know much about it, but I know that people use it. All right. I did it on Rust using Rust bind gen. Oh, okay, yeah, that's the one. But anyway, so yeah, going back to the actions, so now, you know, the free sort of like example that we get here, I believe it did work. We can see it here. So it no, it didn't work. It didn't work. Let's see why it didn't work. Because we could not compile expected to generic arguments. Okay. So see, this is good because my code is not compiling for this version of Rust here, and I don't actually know what version of Cargo they've got. So do we know? Oh, we do know because it was here somewhere. Yeah, we can see the software that's included. Yeah, supported software is what I'm looking for, and then 22.04 is the one. And if I look for Rust, so the Rust version is 1.73, and what do I have on my project here? So if I open a different folder, Rusty crawler, because I guarantee the you know, it builds for me, so I wonder if it's a Rust version difference that's causing it to fail on the pipeline. So that's what we're gonna find out. Cargo version 1.72. Yeah, so it might be a Rust version difference. They've actually got a more up-to-date Rust here than I do, which is cool. But anyway, we can fix that, right? So we can fix, because we know what the issue is. For example, in this particular case here, and let me actually pull my repository in the first place. In this case here, what we do have is that cannot find links in this scope. Links are next. Okay. Why not? Good, so we're getting that as well locally. Yeah, there you go. So we cannot find links in this scope. Yeah, so I'm kind of just willing to just remove this for now. And then also not include this file because it's not done yet. So let me just go back here on this file. Yeah, this is some work that we started in the previous repository, in the previous video, sorry. We didn't really finish, so it doesn't compile, as you can probably guess. But if we remove the file for now, result. Links.next. Yeah, okay, so I see what this is doing. Can we ignore a file? Because it's compiling anyway, so it's compiling that file anyway. So cargo ignore file. So I'm just looking for a way to sort of ignore the file so we can pass the build pipeline on GitHub, basically. Is there a way to ignore it? So I'm wondering now. I know that if I go to my sort of main file here, there is like some sort of like excludes or something. I don't know. I can't remember very well what it is. But I guess we can look at the manifest definition, right? Files to exclude when publishing. Okay, no, so this has got nothing to do, I guess. So package. Yeah, but if I do exclude and I have src, model. Does this work? I do wonder. Nah, it still compiles that. Is it because it's been used somewhere? Link. Ah, yeah, here. I'm a massive idiot. That's probably what it was. There you go, it's fine now. Let me remove this change here, because we don't need it, actually. And if it compiles locally, it's probably going to compile on the pipeline too. So in essence, this build pipeline already brought to me already brought to my attention the fact that my project wasn't compiling, right? And that's a good thing. Every time we do a push, it should tell you whether or not something compiles. So yeah, so we're gonna fix this and we're gonna try and run the pipeline again. So okay, let's do a get status and let's add the changes to this now. Let's call it fix pipeline, right? It's our first fix pipeline push. And commit messages like this tend to annoy me a little bit when you work somewhere and then you go through that history and all you've got is like fix pipeline, without saying what it actually was. But oh well, I mean, we've all been through that, I guess. Yeah, so in essence, what I'm trying to do now is I'm trying to see whether or not my actions will rerun. There you go. So it reruns automatically. So why does it rerun automatically, by the way? Because if you look at the GitHub workflows YAML here, so this on sort of section here tells GitHub Actions when to run this pipeline, right? So here it says, whenever there's a push to main, it's going to run. And whenever there's a pull request onto main, it's going to run as well. And this is actually a very good, initial setting if you want to just use this here. But you can have more complicated things like, so whenever you push something to a particular branch that's not main, you can have that. In fact, if you look at the workflow syntax here, so you can look at on, for example. Ooh, on is going to be everywhere, right? I guess. There you go. So on is the section you want to look at because it tells, as I said, GitHub Actions when you want a pipeline to trigger. Usually, yeah, this is called triggering in other pipeline providers. And there are many sort of like different types of logic you can have here. So you can have filters. You can only run, for example, things on release pipelines. If you want to run a particular workflow in only the release tag, the release branches, for example. If I'm not mistaken, you should be able to do like scheduled runs as well. So for example, run something every time at like 11 PM or something like that. There you go, on schedule. You can, run things at a particular time, and usually it's a cron timestamp that you set to it. So like this is every, there you go, every day at 5:30, so 30 minutes, 5 PM. And 17 UTC. I don't understand this bit here, yeah, because it's been a long time since I've dealt with cron. But this is what you'd be looking at if you want to run something on a schedule, like every day, a particular time, or every other day, or every week, every month, or something like that. This is supported by GitHub Actions as well, which just shows you how sort of like flexible something is. And this is where you're going to be basically spending most of your time on this particular page here with the documentation to sort of like the entirety of the the GitLab workflows YAML. So I'm actually gonna post that in the description. I'll post it here as well if you guys are interested, because it is useful, right? And this is what we're going to be referencing in this video. Okay, so going back to my pipeline, did it run now? There you go, fixed pipeline, did compile, so we are green now. So this is a really good thing to see. So there you go, we build it and we are running smooth here. Okay. Good. So let's see how we can do a, this is basically just one stage, and we've got the build stuff here. So let's see how I can create a new stage, because as we said, we also want to run a few extra things. We want to run, for example, cargo FMT and cargo clippy. This is before we actually build, right? So we're going to try and do that thing. We're going to add a few jobs. There is no mentions of stages here, and I do wonder if Google is probably going to be a little bit more helpful. So stages and GitHub Actions. Let's look at the understanding page here. I want to see how, there you go. So the layout here. So you can configure a GitHub Actions workflow to be triggered when an event occurs in a repository, such as a pull request being opened or an issue being created. Your workflow contains one or more jobs, which can run in sequential order or in parallel. Each job will run inside its own virtual machine runner or inside a container. As I said, you can use Docker containers as well, and has one or more steps that either run in a script that you define or run in an action, which is a reusable extension that can simplify your workflow. So workflow, this is something that changes a little bit with GitHub Actions. They use, I guess, workflows instead of stages. I'm not entirely sure. All the CI providers just tend to call them stages when you have like a collection of jobs. So this is what I'm wondering right now. By the way, I'm learning with you. I have done a lot of GitHub Actions CI, so this is me just kind of learning this with you guys. And is the point of this stream actually. The workflow is a configured automatic process that will run one or more jobs. Workflows are defined by a YAML file, triggered by an event. Workflows are defined in the GitHub Workflows directory in a repository, and a repository can have multiple workflows, each of which can perform a different set of tasks. For example, you can have one workflow to build and test your pull requests, and another workflow to deploy your applications every time a release is created. And still another workflow that adds a label every time someone opens an issue. So this seems like a workflow is a stage here. So what I'm wondering now is, can you have workflow dependencies? Because we want dependencies between them. So we want the build workflow to only run when the fail fast succeeds, right? So we want this fail fast workflow to be a dependency of the build here. So that's what I'm wondering here. We don't care about the events or the jobs yet, because these will be the same definitions as the other CI providers, probably, right? So yeah, as I said, each workflow seems to have their own YAML file in the .github/git workflows directory. To be honest, I like it. I really like it because it seems that you have like one YAML file per stage or per workflow, which is a little bit different to something like GitLab CI or Circle CI, where people tend to add a lot of things into one YAML, even though you can split it into different YAMLs. This kind of forces you to do that anyway, because you're going to have like a different workflow for build and a different workflow for releasing, for example. This is better than Jenkins. Yeah, definitely better than Jenkins. Jenkins got their own language, right, Slim? We do actually have some Jenkins pipeline that work. Is the Jenkins, it's like a Java language. I can't remember what it's called now. I remember doing a video on it. Groovy, yeah, that's the one. No, the way you describe pipeline, it's not Groovy, is it? Is it called Groovy? Pipelines as code. The Jenkins files are root directory. Yeah, it is Groove. Yeah, you are right. You're correct. Yeah, sorry. You probably do that at work, right? Yeah, it kind of reminds me, you know, it's very different to YAML and the other providers, but kind of reminds me of Java for some reason. Is this? Yeah, I think Jenkins is written in Java, isn't it? I have no idea. I have limited exposure to it, thankfully. But yeah, this is definitely better than I guess, you know, Jenkins. But also, I believe it's better than GitLab CI YAML and also Circle CI and Azure as well. They all have the same sort of ideas of stages and then jobs running within those stages, and everything is inside like one file. But this forces you to have a different file and a different sort of like containerized file for each different stage, I guess. So it's not too bad. Yeah, so my main thing is like GitHub Actions workflow dependency. There you go. This is a very common question, it seems. Oh, there's already an answer here on Stack Overflow. Yeah, very cool stream topic. Hey Antonio, welcome to the stream, man. Bem-vindo. Boa noite. Yeah, we're gonna learn some. We're learning, I guess, some GitHub Actions CI. So we've already got a build thing running here for the Rust project. So the idea is to, if you missed out, we're gonna have a few different stages. So we're gonna have like some checks, and then after the checks, we're gonna build, and then after the build, we're gonna run all the tests, and then publish the artifacts, so the build files, right? So right now, I'm kind of stuck learning how to have dependencies between workflows. So I have a money repo with 2 workflows. Okay, this doesn't work. I can reference a job. Now it's possible to have dependencies between workflows on GitHub Actions using workflow run. Okay, I'm gonna just open that. Using this config, the release workflow will work when the run test workflow is completed. So name on workflow run tests. Ah, okay, cool. So events that trigger. Okay, workflow run. Last commit on default branch. Workflow. This event occurs when there is an activity related to a run of a GitHub Actions workflow. For more information about workflows. Okay, cool. Okay, so this is available for repositories, which is good. We should be able to use it. Yeah, so let's try that. So we've already got the build here, right? So obviously we want to, you know, let's keep this as it is. Let's call this is actually called the build workflow, right? Let's create another workflow for the, I guess, fail fast. And then obviously we have the name here. It's going to be called fail fast. And the only thing that's going to change in our case is, I guess, I don't know what this users does yet, so I'm gonna keep it as it is there. I guess it checks out. Yeah, this seems to check out our repository. And then we have the steps, name, build. Let's call this the cargo FMT. And then we're gonna use the cargo FMT command here. Let me just remind myself what the FMT options we have are. Because I know that if you just call cargo FMT, it will format your entire code. And I kind of just wanted to check. I don't want it to format. There you go, dash check. So if I do cargo FMT check here, we should get a lot of things, hopefully. Yeah, a lot of things here. And this is what we're going to do here. So let's run that. So cargo FMT. And then we've got check here. Is there any other options that seem appealing to me? So verbose, use the verbose output, no output printed, stood out, package, format all package, and also the local path based. Okay, so yeah, I guess we want to do all of them, right? So we kind of want to do this. check and all here. Cool. So that is going to run the format, but we also want here the static analysis, right? So we want the cargo clippy analyzer. So again, this should already come with cargo. If I do cargo clippy help, and this does the static analysis in Rust, basically just comments on your code style and whether you're following good practices, I guess. It's a little bit different to the format one. No dependencies, run cargo only on the given crate without linting the dependencies. That could be useful. I'm not sure if we're going to need that. We don't want it to fix automatically. We don't want the version. This is to explain some sort of rule, I guess. Okay, yeah, so what if I just run cargo clippy here? Is it gonna fail? Yeah, that's good, that's good. These are all warnings though, so if I still... sorry, yeah. My point is, I think this is not printing errors, right? This is just printing warnings, which means the cargo clippy isn't returning a non-zero value to my terminal, which means the pipeline is not going to fail. Which, by the way, this is how pipelines usually work. Every one of these jobs that we have here kind of, has a command that returns either a fail or a succeed. And usually fail, I believe, is like succeed is 0, right? And then fail is anything else other than 0 in Bash. So my question is, has this returned a succeed? There you go. So it's a succeed. Can we turn this into errors if there's a warning though? That's my question. So cargo clippy help. Prints this message. Yeah, I mean, how do we do that with cargo? This is a quick Google search. So cargo clippy error on warning. That's what I want. Oh, it's -d apparently, right? Doesn't fail on warnings. Okay, let's try that. Let's do cargo clippy -d there. Unexpected argument. What the f? Cargo clippy -v -d warnings regarding your issue in the above post URL that you used. Instead of -d warnings, use additional d. Huh? No, the additional. Ah, okay. So wait. Yeah, no, this doesn't work for me. It doesn't work for me at all. Is there something in the help that I'm really missing out or something? Cargo clippy help. Deny. Yeah, so -d is what I want. Right? I want to deny, and I guess warns or something. So cargo clippy deny warnings. Unexpected cargo clippy. Oh gosh. Is this gonna work? There you go. Good, good. Yeah, it's just I guess it was taking these as my sort of like arguments to my program instead of cargo clippy. That's fine. So -d warnings should work as well, right? Just to make sure, so if we print it out, there you go. So 101 is what we return, which is an error. So that's what I want here, right? So yeah, let's run that. So cargo clippy -d warnings. Cool. And this should basically do that. This should basically make things work. So also I want it on push. Okay. And then this is where we apply the dependency, right? So where is that dependency thing? It's important to know the release workflow, times completed. Okay, so workflow run. Can I do this? Oh yeah, no, this is not the one. Yeah, no, we do want it on the build, right? Yeah, we do want it on the build. So when I run on here, workflow run. And what do we want? Workflows. I think I called it fail fast, right? It has to be the name of this other one here, which is good. And yeah, let's see if it works now. So to summarize, this is what we've got. We've got this thing running here. So the fail fast is just usually fail fast checks like cargo FMT, clippy, whatever. And then we've actually got a build here as well. So yeah, let's take a look at this whole thing and see if it works now. And obviously I'm expecting the fail fast to completely fail, because as we saw, cargo FMT errors, and so does cargo clippy. But that's something that we're gonna experience firsthand here. So that we want to add this one too, and then we also want to add this one. Good. Adding fail fast stages / workflows, right? Good, good. And now, if we take a look at, I kind of guess that, you know, the very first one is going to run, so the fail fast is going to run, and it's going to fail, then we're going to have to fix, but then it's not actually going to run the build one after, because, right, I'm not entirely sure how these conditions do work here, so when to trigger the pipeline, because we have a workflow run here, which says, you know, run whenever fail fast runs. But are they added together? So are they like anded, if it makes sense? So like it runs whenever the branch is main on a push, or pull request, and when the workflow run fails, because this is kind of what I want, really, right? I kind of think that this is an or, so it either runs when it's a push to main, or when it's a pull request onto main, or whenever the fail fast runs. So ideally in my build one, I kind of just want to get rid of those two, right? So whenever the fail fast runs, that's when I care about running this. And the fail fast, of course, has to run whenever I actually want the whole pipeline to run. So this is kind of what I want to test out in a second. But yeah. Ooh. There's a lot of things here. So adding fail fast. So why is it building? Where's my fail fast stuff? Hey Matt, please watch this, please. Jose Carlos Siqueira Jr., welcome to the stream. By the way, dude, I can't see the links because YouTube doesn't let you post links, by the way. So it may appear on your screen. You know, this is, you can see it there on the screen. I can't see it. So if you want to send me a link, make sure to go on the Discord channel and send me there. Okay. And welcome, bienvenido. Yeah, I'll be waiting for the link, dude. So if you super fast Rust Docker builds with super small images using multi-stage cargo chef Rust Lang from Chris. Oh, okay. I will definitely. I guess it's on YouTube, right? So let's do that. This helped me a lot. Docker builds with small images using. Cool, yeah. Dude, this is 48 minutes.
How you can speed up your Docker builds for your Rust.
I'm not gonna watch it all now, but I'm definitely gonna add it to watch later. And also, I want to see what he kind of does here. Like, what is he using? Oh, I'm already gonna like it just because, you know, content creators, gotta help them out. Where's my watch later? There you go. So yeah, what is he actually using? So create an Actix web server. Yeah, so it's creating an Actix web server in Rust, and it's creating a Docker file what is he actually doing? So he's using the Rust base Docker file.
When I did a cargo run that you saw earlier, what it was doing there is doing a debug build. Now I'm doing a release build. Now that that's running, the last thing I want to do is start my application. So we'll just say start the application. So whenever I start my Docker image, then what I want to do is run that command. So in that case, we will use the cm.
Okay, so he's just basically just getting the Rust base image and applying his app to it. That's cool as well.
V command.
Create an xdoc, okay, Docker ignore. Building a Docker image, yeah, it's just building it, running on Docker container.
Advantages of Docker.
I will definitely watch this, dude. Like,
is do another build when you're doing a build.
this is going to be useful. It's going to be useful. Thank you. So, Jose Carlos, and congrats for your VODs. Oh, thank you, man. Thank you for the support. Do appreciate it. And yeah, stick around if you might learn some. I mean, I guess you already know GitHub CI, right? So you probably don't need to stay around. But anyway, going back to this, why did this not build? Why did it only build the Rust one? Because I swear to God, I replaced. Ah, there you go. Yeah, so I don't want to run this. Let's change it to whenever the fail fast runs. That's when I run this, and I'm gonna call this build. Right. Now, let me push that. Oh. So, Jose, where are you from, man? If I had to guess, I'll probably say Brazil. Brasileiro, né, cara? Okay, dude, why is it not copying? I still got the video title copied here. So git add, there you go. Brazil, knew it. It's the name. You look at the name, you always know when they're Brazilian, like myself. A name like Mateus Gomes can't fool anyone. He's Brazilian. Yeah, so we've got quite a lot of Brazilian people here. We've got some, I guess, yeah, I haven't seen the Indian guys in a while. I used to have a few guys from India as well, Dana J, and I kind of miss those guys now. Hope they're doing okay. And we've got Slim from the UK as well, so quite diverse. I like it. Quite add, commit. So we just renamed the Rust, the build workflow. Added the dependency. All right. There you go. So build is running, right? Build is running when it shouldn't be, because I wanted the fail fast one to run first. Yeah, so fail fast does run. But why are these running? That's what I don't understand. Because fail fast just failed. It failed right now. Like, and it failed on, I guess, on, oh, there you go, on cargo FMT here. Which is kind of what we want, really, right? So, you know, it just failed on cargo FMT because my project isn't formatted, and this is an easy fix. But my main issue is that this also ran. Sorry. Going back. This also ran, the build one. When it's not supposed to. And is it actually running? Yeah, it's actually running. So how do I stop? Where is that continuous integration there? Ah, types completed. Okay. So we forgot this. I think that we're actually saying that we should run the build one whenever fail fast runs as well, but whether or not it completes, that's the problem. So is it completed? Let's see if that's the actual case though. And this song kind of sucks. Oh no, It's Tetris, isn't it? Yeah, that's kind of good actually. Just took a while to get going. Yeah, so workflow runs, and then I kind of want to see the type. Where is it? Event, blah, 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 blah. Is there a types? Types. Properties of workflows. No, we don't. So this is probably not the right types here. I don't know if that makes any sense actually. Action value completed. So workflow runs, workflows. How are these people doing here? It's important to know that the release workflow in your example will run whenever the run tests workflow complete, regardless of it. You need to inspect GitHub event workflow will run conclusion if workflow outcome is, which, yeah, this is what I want. This is what I want. Currently, there are only 2 types of requests in a complete workflow. As a workaround, you can use the expression GitHub event workflow conclusion to get the result of the previous workflow run, and use the jobs if condition to skip. Okay, why is this more difficult than it should be? Yeah, no, this is one of the things I already don't like about GitHub CI. You should just be able to say, run this workflow whenever this other workflow runs and succeeds. How would you use when you have multiple workflows? I assume that both CI and linters both. Workflow CI linters, types completed. It might not be possible to wait for both parent workflows to succeed and then run the production deployment unless maybe this is not the way to do it. Maybe I should be defining everything in one workflow. I don't know now. I'm kind of doubting myself. Oh, this guy's shitting on them. How was this ever considered useful or fit for production? I do agree though, why did they decide to sort of release something that will, you can define a dependency, but it will run regardless. That is not useful at all. Is this really the way to do it? Workflow run is so useless. I was shocked to see the workflow triggered regardless of fail or success. This is my reaction right now, to be honest. This is so bad. An alternative to, okay, workflow run conclusion dispatch action. This action is to be used when workflow run event. It allows for a finer grained response to a workflow run. Example, let's see. So this guy has a workflow which depends on another workflow. And types completed. Yeah, but this is not a workaround though. This is just someone's. I mean, this is a workaround, I guess, but it seems so unnecessary to have this. Nah, I don't like this either. Why is this not possible? Is it? It can't be the only way to do it, right? Let's see if this is going to help us a little bit better. Yeah, it seems to me that everyone complains about this dependency thing with workflows on GitHub CI. I'm gonna assign myself another 5 minutes to look into this, and if it doesn't work, I'm just gonna put everything in one file. I don't even care. No, we don't want to cache dependencies. Default branch, not default actually triggered. This is possible with a combination of workflow call and needs. Adding workflow call to the on. Maybe this is a little bit better. This is a great solution, very clean in my opinion. This solution. Okay, this is... I could have just scrolled down a little bit more, I guess, but I decided to go on an off tangent. If I just scroll down on the first answer, I would have found something that's maybe useful. So for your case, on workflow call, allow this workflow to be called from other workflows. Okay, that's interesting. I didn't know you can do that. And then this is a deploy one. Tests, deploy, require tests to pass before. Whoa, this is great. This is actually fucking... Oh, sorry for the swearing. This is actually good. So this person is basically... They have one file for like the tests. And that is like... That can only be called when the workflow... When it is called as a workflow, right? And then they've got another file, which I guess has every logic in it. Or the logic in it, that kind of has a job that uses the tests. And then another one called deploy that then deploys. So these ones, these two I guess run in order, right? So deploy only runs when tests run. I don't see why I didn't think of that in the first place, but this is great. I'm gonna definitely use this. So let's call one of them like the entire pipeline.yaml. So I'm just going to copy and paste the solution here. Any entry in the respect. Yeah, good. So for now, let's just do something like this. Let's call it the build pipeline. So in fact, this is what we want on the build pipeline. We want the actual triggering. And then the jobs, we kind of want the first one, let's call it the fail fast. Call fail fast.yaml here. And it uses that one. And then we also have another one here, which is the build, right? So the build one uses, and then we've got the same kind of thing, I guess, in here, where we just have build.yaml. and we don't need to deploy now. But in this too here, I guess on what we do want is just a workflow call. Yeah, so we have that one, and this one will be the same thing here on workflow call. There's no way this is gonna work, right? There's no way, absolutely no way. Let's see. And if it does, I'll explain how it actually works in a second. But basically, we're just encapsulating multiple workflows within one sort of major workflow. Right, cool. Yeah, the downside to this, as the person said here, is that they might not get a tab for the logs, right? So in here you can kind of see, I guess, the tabs here. Bye bye, dude. Gonna watch later. Thank you, José. Muito obrigado, cara. Boa noite. I'll see you in a bit. Yeah, we might not see the tab in here. So all workflows. Did we not have a name for it? Build pipeline. And it didn't run. Why didn't it all run? Ah, it's because we didn't add this one here, that's why. I'm gonna have to kind of force push into the other one. Just gonna include in the previous one. Oh. No. Pick. Okay. There you go. I just amended the previous commit, so it also includes this one. So this history looks a little bit better. There you go. It didn't work. Invalid. So what's the issue? Users, GitHub, workflows. YAML was not found. Yeah, it's because it's not YAML, it's YAML. Sorry about that, guys. Just a typo in the name. What else do I have him? Yeah, I do. Git config. Is it editor or something? I want to set the editor to Vim. I'm just going to Google. I can't remember. I noticed that is gedit or gedit by default, and I don't like that. There you go. That's what I want. There you go. So now if I do git rebase, I should have Vim here, which is I do. And there you go. Easier to force push now. There you go. So encapsulating the workflows into one, and there you go. This is what I expected to see in the first place. Something like this. So in the logs here, we kind of have the build pipeline, and this is the pipeline that's running at the moment. And when you click on it, you have all the stages and everything else, right? And why didn't this kind of stop this one? No, we're still happening. My build is still happening, even though the fail fast is running. But there must be a way, right? There must be a kind of way to say that if one job fails, they all should just stop running. There you go. let's just change this a little bit better as well for the logs. So we actually have another one called, this is cargo, it's the format check. And this is the static analysis. And this is what we have here. Okay, cool. We probably want the runs on in here too, to make sure it runs on Ubuntu. So we've got the steps, and boom. Good. This should be a little bit better. Hopefully this is not going to give me a syntax error. Just to make sure, let's let's put that there. So yeah, I've got FMT running here, and then static analysis running here on a different job. Now, the problem I'm having is that the build job is still running after the previous job has failed, right? So GitLab, GitHub Actions, stop jobs, if failure, or something like that. Ah, we can put needs. We can put the needs there. Cool. Needs build. Cool. So, yeah, we can do these things in parallel. We don't really care, right? These two can run in parallel or at the same time. I don't really care. But in here, we kind of want to put the needs there, and then we want to put fail fast. Right? This is what we want. Cool. I think this should be now. This should be it now. Oh yeah, if you're watching this, I'm not sure if there's still anyone watching. A quick trick that I've been using on the videos and stuff for many months now. If you have a lot of files on Git that you've modified, so if your status looks like you've got 10 files, something like that, there is a git add -i command where you can interactively do this. So you can say, for example, I want to add the first and the second file like this, or you can just add 1 to 10 or something like that by doing a dash, and you'll add all the files and so on. So yeah, kind of neat, kind of very easy way to sort of like interact with Git using the command line, and I kind of like that. It's included in Git, by the way. So git add -i is what you need. Try that out. I'm just going to push this again. And let's see what it looks like now. Okay, so we've queued just now. Really good. This is good. This is good shit, guys. Look at this. Build is waiting for my fail fast now. That's what we want. And of course everything fails because it's going to fail anyway. But this is an easy fix now. We got the pipeline kind of working. Let's just summarize what we've got so far. I don't want to go too fast. We've got this fail fast stage here, and then we've got the build stage waiting for the fail fast, right? That's what we have here. Okay. So yeah, let's actually fix the pipeline, right? So every step that we do, every sort of like little pipeline thing that we add, we're gonna have to apply fixes to the code, right? The first fix is easy, so it's just running a cargo FMT, which is gonna format all my code. And if I do a git status, I can see that most of my files were formatted. And again, I can just do a git add -i, and I'm gonna add all the files here because they're all Rust files. I can see it here, so 1 to 6. Added all of them. And then I'm gonna, commit my fixing the formatting of my Rust files. And there we go. I'm still the one. Hey Slim, I'm glad you're here, bro. Yeah, I mean, these messages are taking a while to get to me. for some reason. I hate YouTube streams. Maybe I should be on Twitch instead. Did I push it? Did I push it? Yeah, I did. So in essence, it should be running, right? So my formatting task should be running. Something failed again, but as we can see, we fixed one of them. We fixed the formatting check by just running cargo fmt on the code. Now is the static analysis fix, right? Unexpected -d. So there's actually an issue with my command itself. I didn't realize that. So if I go to my fail fast, this command doesn't run. Oh yeah, it doesn't, because I remember I had to do that. But I'm sure it would fail on the pipeline anyway. So if we copy that and paste it here, there will be issues, right, that we have to fix. There you go, many of them. Well, I am 3 minutes behind, lol. Yeah. Yeah, you are 3 minutes behind by the looks of it. I don't know why it's 3 minutes, dude. Maybe YouTube just adds this. Like I choose the low latency for my OBS streams every time. There isn't a lower latency than this. So I don't know why it's so long. Maybe it's for, I guess, privacy reasons or something like that. It kind of makes sense, really, not to be on real time. But, you know, 3 minutes is way too long. Anyway, so yeah, this would fail on the pipeline. So let's just fix this once and for all. So the first fix, for example, is the source crawler on line 53. Need to change this to path, okay. So line 53 here. This is a very easy fix, just remove that. And then crawler line 58. Again, we change that to just path. And then 173. This error here that I'm looking, just change that to client. I'm loving these fixes because these are so easy. I don't have any messed up ones. Now this one here, what is the issue? Map. Try replacing map with flat map and remove the flatten. Yeah, we can do that, right? Because images.clone. Okay, flat map. I guess flat map does a map and a flat at the same time. So yeah. So a flat map will, okay, that's cool. Now before I lose myself, let's run cargo clippy again. And those few issues at the start should have disappeared now, which is good. What's the issue? Change this to destination. Again, a very easy fix because we already have a, I guess, yeah, this is already a string. So we were passing a reference to a string when a string is already a reference. Change this to client. And then this one here. So what's the issue? You seem to be trying to use match for destructing a single pattern. Consider using if let. I am doing that exactly. So if let, what is the error e equals result, and then I just put that in here basically. How much cleaner is that? Very good. And now we should have all the issues fixed, hopefully. No, we don't. Redundant pattern. Oh yeah, okay, I see what you mean. There is a, you're gonna tell me that there is a function for this. First is none, right? There you go. Cool. So what have we changed? Let's just do a git cargo fmt again to make sure. And yeah, let's go for it. So we're gonna add all the files 1 to 4. Now we're not gonna force push this. So what did we do? We fixed formatting and then static analysis pipelines, right? We don't want to put force push this time. So I expect the fail fast and the build to be going through now, right? So we click on that, and here we are. This is amazing. I love this. I love the way in which we compose I guess a complicated, it's not really complicated, there's only 2 stages, but a complicated pipeline from different workflow files. And one thing I don't like is obviously the lack of support for workflow dependencies in GitHub Actions YAML. But I guess, you know, this will have to do for now. It's not too bad. You see, this is why I sometimes don't add the fail fast static analysis to the fail fast stage here, just because it's not really fast. I mean, it takes just as long as building, but you know, it is usually a check you want to do at the start anyway. And my neck is painful today. My neck is painful. There you go. Now I expect build to go through. This is beautiful, beautiful. Setting up the job. Okay, this may take a while. Right? Can we see the real life, the real time logs? Good. I do wonder, because we essentially defined 2 different workflows in the same YAML file. That's what we're essentially doing, which is like using them as templates. If all the files generated in this stage here, we call it stage, but really is a job, in this job, if it's also going to be available in here, because we might have some issues with building, I guess. I mean, if you're building with, you know, with many different settings, for multiple platforms, you probably want to keep all of those like build files separate, because if you just do it all in the same thing, it's probably going to override each other, and that's not something you want. But we're not going to worry about that in this live, because we only have one build, right? That's what we care about. Yeah, there's no tests run, by the way. So that's good. Oh no, it seems, yeah, he builds again. Like run tests is building it again from the looks of it. Oh no, it doesn't. He kind of used the cached one. That's good, I guess. This is insane. Yeah, this is good. I like this. Completed the job and it passed. Yeah, one thing that you've noticed is probably that we have the build and the test in here. So we kind of have this at the moment, and this test doesn't exist. I kind of like keeping it separate, so I'm going to move test into a different workflow file. So yeah, let's try and do that. I mean, now that we know how to work this out, it's very easy, right? So yeah, cool. Can I delete these workflows here? So build pipeline, let's disable that workflow. I kind of just want to, oh no, I want to enable the workflow, my bad. I want to delete this build one here, disable workflow. Disable workflow? Like, does it still run inside here? That's what I mean if you disable it. I don't know what that means. I don't know what that means, but yeah. Yeah, looking over the CI as well, we have cache. Is this where we push stuff to? So view a list of cache entries for a repository. Maybe not. But we do have a runners tab here. Okay, so we have we can see which runners you have here. So we can have self-hosted runners. That'll be a cool video in the future, right? Setting up my Raspberry Pi or something to be a self-hosted runner. So basically a runner that I own. Pretty sure I can do that. So like Raspberry Pi for GitHub Actions runner. There you go. So you can install this stuff on ARM from the looks of it. That is very cool. Yeah, let's leave that for a future video. But anyway, going back to my actions, yeah, let's separate that that test file, right? So we have a new file here called test.yaml. I'm just going to copy my build one. For now, I don't really care about repetition. I'm sure that there's ways you can have less repetition in these YAML files. For example, GitLab CI and Azure Pipeline CI, Circle CI, they all have like templates that you can kind of like just reuse CI infrastructure basically. But you know, in this I'm just going to be copying, so I'm just going to be running the tests here. So we have tests, runs on the Ubuntu latest, we have the action to check how, and then we have this here. I'm not sure if we want to check out. Can we just run the tests without checking out? Yeah, let's clear one thing. So what happens when you finish a job and you go into another one? What happens to the files that you've created? What happens to the, you know, everything else that was in the previous job? Keep files between jobs. You can use the upload artifact and download artifact to share data between jobs. Okay, so no, it doesn't get kept. But this is going to be useful anyway, because right, yes, we don't want to kind of, I guess, kind of like build everything all the time. We're going to leave the checkout here, but if I just do this as it is, this is going to build my project again. It's not going to use the files from my build here. Because they will disappear after the build. That's what it means here. So ideally what I want here is to have some sort of like you know, push artifacts or something like that. Push build artifacts. And this is where I push all my builds, which I can then download on the tests to then test it out. Here, artifacts. So let's see how we can do that. Upload artifacts v3 with homework path. Okay, so happy to just copy and paste this. So upload the build files. Users upload artifacts to be free. Name, build, path. Okay, so what can the path be? That's my question. I want to upload a whole directory. So this is downloading it. Where's uploading it? There you go. Retention in days. Value cannot exceed the retention limit set by your repository organization or enterprise. Usage. Here we've got the usage or path to artifact. Upload an entire directory. Okay, so it's just a path to the directory. It's okay. Yeah, we can do that. So what do we have? We have target build, I believe it is. Wait, what is it? It's a target debug, right? Yeah, there you go. So we want target debug. Now I do wonder if it's gonna also include the target directory itself when it uploads it, or if it's just gonna basically upload debug onwards, and then when I unzip it or when I download the artifact, if I'm just gonna download the debug directory, or if I'm gonna get target/debug inside it. So we can find that out with a cd command. That's not a problem. That's cool. So we can do that in the build target, and I guess what we have to do then is to do the same but for the download artifact, right? So download to a specific directory. This is kind of what we want, I guess. So users download. Okay, so this is kind of what we want in the in my test YAML. So in here, I also want this. Oh no, I don't. What I want is this. Oh, it's also not what I want. I want to copy this and then paste it here. Users, and then we've got with. There you go. And this is going to be build, and I'm going to download it to target. I'm just gonna add this for now because I kind of have the feeling that whenever it downloads things, it will go to the wrong directory. So I'm gonna add a run here that will just say tree. I'm hoping that they've got this on the on the runner on the GitHub runner. Because tree just shows you the directory tree, basically. I just want to have a view of what it looks like. Okay, why is it taking so long to install tree? Ubuntu, come on. So if I do tree now, you can see, a lot of stuff here. So depth, I think 3 will do. Depth 3. There is a maximum depth somewhere. It's pattern, file name, pattern. Seriously? Maximum depth is not a thing? Level, dash F, okay. Missing argument to... Okay, there you go. So it only prints like down to 3 directories or something like that, right? Which is kind of what I want. So run tree -L 3. And okay, this kind of needs, right? I'm gonna put a needs the build here. Oh no, it doesn't. However, on my build, my upload does need is this how I do it? It needs... So I'm a little bit lost. Why did I use needs? Okay, on here. Yeah, this is what I want. So it needs the build. There you go. So it can only upload if the build succeeds, and you get the gist. You get the gist of it. And then fail fast has all this shit in it. And I've got a new test one here, which is a workflow call as well. And the only thing that remains is for me to call this here. So I do my tests, which is gonna use the, I guess, the GitHub workflows. We've got tests, or test.yaml. And then this needs the build to succeed. Okay, so there's a dependency now on them. Okay, good. So let's see if we can push this, right? So all we did here is we basically added a separate test workflow. So I will check if the test one kind of runs by adding a test to my project in a second, I guess. So all workflows add a separate test workflow. Failure. Why? Error parsing code. You have an error in your YAML syntax line. Okay, show more. Okay, I think I've got unneeded or not necessary. Wait, which one is it? Pipeline or YAML? Which line? Line 18. That's interesting. Is it on the build the YAML line 18? There's an error here somehow. Is this not correct? So it's saying that I've got an error here. Oh. So which one is this? This is upload the build. So how are they doing it here? So what? Oh, okay, yeah. So it's just users that, yeah. I'm an idiot. So we have just users there. And then these can kind of go down a little bit. With name, okay. With name, this is the build. Now one thing I don't really like is that I can I not add a name to this step? Maybe not. We can do that, that's fine. Just make sure that on the test I'm not doing the same thing though. Yeah, there you go. So the test one is fine. There you go. Hopefully that's sorted. Okay, I got another half an hour of pure pipeline work. No, we still fail. Why? The workflow is not valid. Unexpected value needs. Which line? Which line? Build YAML on line 18, column 7. Build YAML on line 18, column 7. I guess we can't have a needs. Oh gosh. Can I not have a needs? No, we can. Upload. So this is saying that I can't have a needs in my upload job, right? But I kind of need to have the dependency anyway. So is there no way to say that I've got a dependency on the build? So go. So upload artifact if there. Maybe that's something I can do. So I want to upload it only if it passes. To upload artifacts only when the previous step. Okay, wait. I think by default he only uploads if the previous one passed. I guess that's what we're gonna find out, right? That's what we're gonna find out. So just gonna make sure that my test one, there's no needs in there. Okay. Sorry guys, it's quite boring now, but it's because I'm getting a lot of things that are just wrong here. These songs are starting to be too epic for me. This is just a pipeline video. Okay, hopefully we got it now. This sounds like it's DCMA, so I'm gonna move over. That song is too good to be on the DCMA free playlist. Sorry about that, guys. Oh, okay. Actions. Is it running now? Please tell me it's running. Yes, it's running. And here we've got tests here, which is good. That's what we wanted. Yeah, cargo clippy just takes a long time, doesn't it? Jesus. Okay. Now we should be running the build. This song also sounds really good to be on the DCMA free list, but I'm gonna let it play. Hey, fuck it, if I can't get money from YouTube, you know, I'm just gonna... Well, I'm never getting money from YouTube, guys, that's what I'll tell you. I'm not sure if you guys have seen any content creators talking about it, but you really get nothing from YouTube adverts, so it doesn't matter anyway. Okay. Yeah, building takes a long time, doesn't it? I'm interested to see if this is gonna work here this year. What are we even compiling now? Yeah, waiting for builds is kind of the story of my life. There will be 1,587 files uploaded. Jesus Christ. This is ridiculous. Is that how much there is? So if I go into the target, and if I do a tree here, yeah, there's a lot of shit here. There's a lot of stuff. Look, it's a lot of files. So uploading the entire build directory might actually go over my free allowance on GitHub, which is 500 megabytes. Yeah, we'll definitely go over that. Yeah, so maybe you see, in this particular case, I got to think about kind of just packaging the stuff. Oh yeah, there's a lot of object files here that I don't need. You can kind of see that. So yeah, I mean, I can just make sure that we just go into target debug, right? Cd debug. We just we upload the Rusty crawler and Rusty crawler D, and that's basically it, right? I don't think there's anything else that we kind of need, but yeah. So let's start rewriting the pipeline to do just that. So I'm gonna avoid using a lot of storage here by going on my build and then kind of just doing debug. Yeah, I mean, let's add a new thing here, which is like package files or something. Package. Yeah, I'm just gonna call it package. Does this work? Yeah, it does work. So hopefully this works on GitHub Actions CI as well, where we have a multi-line run. So the first thing I'm going to do is I'm going to copy. I'm going to make a directory called, yeah, I don't know, crawler package or Rusty crawler. And then we're going to copy some files to it. So the files we're going to copy are target, debug, Rusty crawler, anything into Rusty crawler. And that's it. And in my build here, all I have to do is, sorry, my upload, all I have to do is upload the Rusty crawler package, right? But then in my tests, I kind of have to download that build, but then I'm going to put it in path in debug, right? Because that's kind of where we expect it to be. So that's where we're going to put it. Yeah, I think that should be it, hopefully. You see, this is still going, dudes. This is still going, and it's going to take a while. I'm going to cancel it. I'm going to cancel it because we don't really want to do all of that. Anyway, we don't want to upload all of those files. Yeah, and let's see how much faster this actually is. Hopefully a lot faster. I'm hoping anyway. So yeah, so by the time we wrote all of that, you only uploaded 60% of the files. So that's how slow it was gonna be. Yeah, one of the things I can say is, like, be careful what you're uploading. Sometimes, like myself here, you may be trying to upload your build file, so you basically package and upload everything under the sun in your build directory. But there's a lot of like object files, there's a lot of intermediate files that gets generated by the compiler, and these tend to be bigger than your project, than your executable or your library. So yeah, especially object files, they contain every single bit of like assembly for the functions that you can possibly include in other object files, and for the classes and everything like that. So they are very big. So yeah, you got to be careful. If I go to actions now though, hopefully this should not take too long this time. The issue is that, you know, our pipeline is starting to take a little bit longer than it was at the start, because we actually have some checks, we have a build, and we have uploading stuff. So we start wasting more time waiting for it now, which is not ideal, but you know, it is what it is. But yeah, I mean, we're nearly at the end of this completion here. So we've got a build and hopefully a test stage that works, and we're going to find it out by adding a test. And then these artifacts here, I mean, we already kind of have that anyway. By publishing the artifacts, there is a retention time, but I'm gonna see if I can push to a what do you call it, a persistent storage on GitHub, because when you publish an artifact, when you upload an artifact with the cloud providers, GitLab CI, Circle CI or whatever, they tend to be retained for a few days, so they aren't saved there forever. So usually, like after 10 days or something, the artifacts will be deleted. But we want it to kind of last forever, right? If we want to do a release or something like that, we want people to be able to download these artifacts forever. And this is where a more persistent storage like the Amazon S3 comes in. But obviously, I'm not going to be using Amazon S3. I think that GitHub has artifacts, right? Artifact registry or something. Or maybe we have to use something else. So kind of, I'm looking for release artifacts really. So create, release, and upload artifacts with GitHub Actions. So how is this person doing it? Action storage. That's what I kind of, storing workflow data as artifacts. This is not really what I wanted. Anyway, how is our, okay, this is going to be interesting because I want to see what it downloads. Okay, so show the contents. Do we have a tree here? Yeah, we do. So target, there you go, perfect. So you see like it downloaded straight away. Oh, Peter, man, how are you doing? Hello, Peter, hello. Mentor, it's been a while. Yeah, it's been a while, dude. Hope you're still doing well and your studies are still going great. I hope you're doing good. I am doing good, man. Thank you for asking. Thank you for caring. So we're learning about pipelines today, man. Something very important that you should, also study. Yeah, no, this is still compiling everything again, though. Unfortunately. Yeah, so maybe in this particular case here, having a separate test stage isn't too good. And I'll explain why. Doing well, sir, and studies seem hectic. Yeah, I mean, it's good when it's busy, right, Peter? It's good when it's hectic. If it wasn't, there's something wrong, man. That's all I can say. Yeah, maybe, guys, it's actually better to kind of keep the cargo build and the tests in the same sort of like workspace, or I guess the same stage. Because cargo test uses the build files, the object files, and like the build libraries, the build dependencies from the cargo build to actually test your project. And unless this is kind of, I guess, interesting, unless I was to upload the entirety of my cargo build files and then download them on cargo test stage here, running cargo test is actually going to build my project again because it's not caching it. Not caching the intermediate files creating by the compilation stage here. So in this case, I see why, I guess, they, in the example, they had cargo build and cargo test in the same thing. But, for the purposes of having a different stage for the tests here, I'm gonna leave it as it is. But yeah, it's a little bit of a waste now. And if I was doing this for an actual company, I would definitely save money and put these things together, just so you know. Oh, we're doing pipelines today. Let me be quiet and pay attention. Yeah, dude. I mean, feel free to chat. I mean, I love chatting with you guys. Having messages on the chat when I'm doing a stream is actually much better than not having messages. So yeah, do post any questions or anything you guys want to just chat about, because I do enjoy that. I mean, that's why I'm doing this, right? But yeah. Yeah. So I'm contemplating whether to move it back here, but let's, for the purposes of following the plan that we had at the start, let's leave the cargo test separately here. And also, as you can probably guess, we're not really running any tests at the moment because we don't have any functional tests, right? Sorry, we don't have any unit tests, and this is what we kind of wanted to do. So found 0 running tests, right? So there was a test somewhere. I can't remember where. Was it link? There you go. Yeah, I did have a test here. So this was supposed to be here. Use create model link. Okay. Use create model link. Image. And I just had one test here. Convert to JSON. No. Convert links to JSON. So we have a hash map, a link ID to link, and then it converts to the JSON. So what did we have before that? Convert to JSON images. You know, I guess just for the purposes of this video, we don't really care about this particular test. I just want to say, you know, a unit test here or something. And at the end of it, all I'm really going to do is having the, I guess, a equals or something like that. Oh, in fact, just a will do. And if I put a false in here and then just run this, if I run it locally here, you can see that it's going to fail, right? Let's also comment this out here because we don't really care about that. And the test fails, right? So I kind of want to just see if this is working on the pipeline. I'm just going to push this. So let's do that. Okay, yeah, I'm just force pushing this because I want this to be part of the test workspace here, so my test stage. And yeah, I mean, let's see if it fails now, because I'm expecting this to fail. Basically, that's what I'm expecting to happen here, just to prove that this in fact works. And if you have unit tests in your project, and if you have any of them failing, it will automatically fail my pipeline and give me a sort of like a red flag or something. And by the way, you know, whenever we get a failing pipeline here on GitHub, it's probably sending me an email. So like I probably have like 40 emails by now, right? Just from working today. So yeah, not ideal, but what can we do? What can we say? It's my one of the first streams without the hat as well, because I kind of got a haircut last week and it's way too short for me to wear the hat inside. So also I hate my haircut, not gonna lie. Every time I get a haircut it's the same thing. It's too short, isn't it? It's way too short, way too short. Alright, so we should have a build pipeline running. While this is running, let's actually think about this next bit. So the idea here is to get that sort of like packaged like artifact that I've got and push it to the storage, right? But it doesn't seem, at least for my searches, it doesn't really seem that GitHub has any sort of like useful like artifactory, like not artifactory because that's a product I guess, but like a persistent storage, right, where my files will be there and they will not be deleted, because it seems like they kind of, I guess the artifacts get deleted automatically after a while. This is typically what happens in other CI providers, so I would assume the same here. So let's see, maybe there's some information on the billing section. So here's storage, or free storage, freeze, GitHub posted. The storage used by repositories is the total storage used by GitHub Actions artifacts and GitHub packages. Your storage costs is the total usage for all repositories owned by your account. Yeah, I mean, I guess like for the sake of it, you kind of understand what I mean, right? So like ideally, guys, we would have another stage where we would get the packaged, you know, this artifacts that we generated in here and push it somewhere where we, you know, publish a release or something like that. So if we do automatic releases, for example, we can have another stage to do that automatic release where we kind of, you know, tag the code, like give it a new version or something like that. Download the artifact from the build, package it up nicely, and then push it to somewhere where users can download, like an S3 bucket or Azure storage or something like that, or even the Google storage, I don't know what it's called, and then do a release of those files, right? But I'm just tempted to skip this because it doesn't really add anything to the tutorial here. Yeah, I mean, you saw how it works, right? I mean, we've already got like the most important bits here. So this would just be another sort of like a few commands on a pipeline where we firstly like log into AWS or something like that. Secondly, and then just push those release files to an S3 bucket. This is, you know, in a nutshell what kind of happens here. So I'm not gonna do that today. However, let's see if our tests will finally fail. And it should fail again because you know, if you haven't noticed, I did add a test somewhere. Can't remember where it is now. Yeah, that will always fail here. This is a unit test in Rust that will always fail. So I expect that to fail. There you go. And good, we get a red line. So this is what we expect. And obviously if we fix this, so if we assert to true now, that should pass. And yeah, I mean, this is going to run again, but it's, you know, spoilers, is going to complete the entire pipeline. One thing that I haven't yet noticed is like, where do my artifacts get pushed to? Like, how can I access them? Because usually you can download them, right? So where can I get my artifacts? So if I go to my build pipeline, is it in caches? No, it's not in caches. So if I go my build pipeline again, so for example, this one here, view workflow file. Okay. And then so here's some stats for you. So overall, to run this entire pipeline with a failing test, it's taking around 4 minutes and 2 seconds, right? Which is kind of long for a very simple project like this. If you take a look at, for example, my C++ projects, I've got like a base64 project somewhere that's quite popular. That pipeline takes around, you know, on a good run, 2.5 minutes to 3 minutes. And it does a lot more than this, I'll tell you that. So ideally we want to optimize this by doing, you know, little things that we can optimize, such as, you know, moving the tests to the same workspace as the build, so it doesn't have to rebuild again, and that will save quite a lot. That will save about a minute and a bit. But yeah, this typing skill set, apart from Alvis Bacon, which seem outdated, which other apps will you recommend, please? Dude, this is just typing skills from like working with a computer for 8 hours a day. You'll get there too, man. I don't know what kind of apps do you mean, like typing apps? I don't really use typing apps, you see. What I can say is just like code as much as you can and try to not look at the keyboard as much, so then you learn sort of like the position of the keys and where your fingers should go. But like, it will come with experience, Peter. Don't worry about it, man. The more you do, the better you're gonna get at it. So just like anything in life, right? So Yeah, I'm still struggling to find the artifacts. So where can I find my artifacts? Where to find artifacts? GitHub Actions. Under your repository name, Actions. Click the name of the run in the artifact section. Sure, sir. Thank you. Lol. Yeah, man. Yeah, Peter. Just practice, man. That's what I can say. It's the best thing you can do. But yeah, man, this is years and years and years of keyboard typing, really. But, and yeah, get a nice keyboard, by the way. So I've got here it's not a very expensive keyboard. I think I bought this years ago for like £50 or something. It was actually quite cheap from Amazon. It's a mechanical keyboard, a Fanatic mechanical keyboard. And if you get a comfortable keyboard, it helps things as well. But yeah, but I'm not one of those that spends like £300 or $400 or something on the keyboard. I don't agree with that either. But anyway, so where are we? So it says that we should click on the build pipeline. And where? Like downloading workflow artifacts. Actions, code QL. From the list of workflow runs, click the name of the run. So if I go into here, for example. Oh, okay, so there's an artifact here I'm just missing out. Right? Ah, okay, you can click on the artifacts. Okay, I see. So if I click on it, I have my build artifact here. And Jesus, is 125 megabytes. That's a bit much, isn't it, for a Rust application? I mean, it is a debug Rust application, but still a lot. And you can see that, you know, this automatically generates me a sort of like a nice enough package where I have my executable here. So if I was building this for Windows, for example, and releasing that Windows build as an artifact, I could well download this and run it on my computer as well. In fact, I can still download this and kind of run it on my hopefully my Ubuntu here. So let's try that. So I'm going to be running the build project from my Ubuntu. And this will be like the icing on the cake for today. So if we manage to do this right, that means the stream went smooth enough. So yeah. Okay, so if I move it from my C users and build a zip into here. Okay, so I can just unzip my build. Okay, I don't have unzip, sudo I think zip or unzip. I gotta be very careful not to mistype my password into somewhere else. I just realized this is extremely risky. I don't actually know what my password is, you know. What the hell? I have like maybe 4 or 5 different passwords, so I'm just trying all of them. There you go, that one worked. So I can now do an unzip build here. And if I do rustic crawler, permission denied, it's okay. Because it's a zip, yeah, when you zip something, unfortunately it loses the executable permission here. But something we can change. There you go, and it seems to be working, right? So this is the file, like kind of the build I generated from the pipeline. So if I do a starting URL, note that this is not on the Raspberry Pi. Usually this runs on my Raspberry Pi, we're on the stream. So this is actually on my WSL machine, which seems to be, you know, working quite well for now. Let's do a max links set to 100. And yeah, that's it. I mean, we can also set a Rust log variable, I believe, Rust log to debug there, or info. And I think that's it. Let's try that. Could not find links. It seems to be working, but before I do that, I also want to enable the log status, right? There you go. Now we can see what's going on. Yay, this is working. So I was actually not expecting this to work because I'm running on WSL here, right? And maybe I was hoping that WSL, well, not hoping, but I was expecting WSL kind of not to work with some of the libraries, or the glibc libraries on the runner for GitLab CI. But it's interesting that it works. So we've got an images here, and if I open this on my Windows, I should be able to see the images that we downloaded with the crawler. Where are we? Where are you? Linux, Ubuntu, home, and then we're on temp. I'm gonna make sure that I kind of don't show all of them to you, because there might be some naughty images that my crawler just downloaded. Hopefully not. Yeah, there you go. So you can see all the images that my crawler downloads from the crawled links. Mostly GitHub ones, and loads of stuff from my website as well. Like, what is this one? I don't even know which one this one is, but yeah, I do recognize most of these images. I've created them, so yeah, guys, I really do hope you enjoyed this video, and we should have, like, there you go. We've got a pipeline that completely passes now. Pipeline that kind of looks like what we aimed for at the start anyway. So I will say though, if you're still here, Peter, check out my latest video on CMake. Make sure you drop a like, and if you can watch the entire thing, man, I would thank you guys, because watch time is the new YouTube algorithm. So the more people watch the videos, the more recommendations they get. So yeah, check out my latest videos, and I hope you guys enjoyed this live, and I'm gonna call it here. But I hope you all have a nice evening, and perhaps we'll see each other again tomorrow. And yeah. See you. Bye bye, Peter. Bye bye, Antonio, Slim. If you guys still here, I'll see you guys tomorrow. And yeah, bye bye.